Hello everyone, welcome to this session, Kubernetes tutorial for beginners. Before starting the session, please subscribe my channel so you never miss an update from me. So let's begin and discuss the agenda for today's session. Agenda for today's session is why do we need Kubernetes? What is a Kubernetes? Feature of Kubernetes, how it works, architecture of Kubernetes, hands-on with Kubernetes. To understand why we need Kubernetes, first we need to understand how the application were designed. In figure, you can see two architecture of application. The first is monolithic and the second is microservices. So monolithic application is nothing, but all the feature of applications are consolidated in a single code base and deployed on the same server. Let's take an example of Ola app, which we generally use day to day. In that, you have a feature like notifications, push, booking management, location, customer care, wallet, and payment services. And all of these component is part of the one application, and that is we call this Ola app. Suppose you click the booking button in the app, then the API query will go to the server and you will see the nearest cab. And again, if you click the payment button, the API query will go to the same server. This looks pretty good to you, but this architecture causes problem because if in future we have to make any changes or update in component, like we need to update location services as there is major update from Google Location API, which I think Ola is using Google Location API, and we are updating the same code base where other component also exist, and that might break something with them, and the entire application will go down and it will stop working. So I wanted to update location services, but update is failed due to some bug, and my entire application went down because of dependency with each other. And we found the solution for this problem. It was microservices architecture. In a sample, you can see that all the feature can have different code base and different deployment server, and all these services will interact with each other over API. But again, there was a problem how to deploy these services and where to deploy these services. Suppose if you have a 7 services for a single app, so you need 7 different servers or 7 hosting account, which is going to cost you a huge amount of money. And management and maintenance for those servers will be a big pain for you. And one of the major issue with this is upscaling and downscaling of your services. Problem with upscaling is your server will not be utilized fully, and downscaling will not be available if any server is underutilized. So solution for all of these problem are Docker. So how does Docker solve this problem? Actually, Docker gives a separate environment to application on a single node. So your entire application only will go down if your physical server is down for some reason. Inside the Docker, your location module running in a Docker container, booking management can run under the booking container, and wallet module is running on the payment container. And also it will solve the problem of upscaling and downscaling. So if I wanted to update any account of or any component of my application, it will not affect other component of the applications. Here you can see Nginx, PHP 7, Redis, SQL, Laravel. They all are running in a different separate environment, and they are communicating with each other over API. So Docker has solved the application problem, but problem is here how to monitor the Docker container. And there is more than, suppose there is more than 200 or let's say 500 container are running. How do I manage those? So orchestration of the container was the problem, and this is where we need Kubernetes to manage orchestration and container environment. Docker also has its own native feature called Docker Swarm to manage the orchestration of the container, but Kubernetes is way more advanced and easy to manage. So problem without Kubernetes, managing container on multi-server environment. Scaling specific services based on a load was not possible. Monitoring of the server and container, because suppose as I already mentioned you have 500 container, it is really tough to locate a single server or single instance of your container, and then suppose that is down, you will never know that your services went down, and you can never fix it because there is no way before the Kubernetes. No automation and huge manual efforts are required. Again, if infrastructure is large, 500 server, managing 500 server without automation is really pain. So, what is Kubernetes? So, as per definitions from the Kubernetes, Kubernetes is a portable, extensible, open source platform for managing workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services support and tools are widely available. The name Kubernetes originated from Greek meaning helpsman or pilot. Google, or I think so, it's a Google project. Google started this project in way 2014, and now it's open source project where lots of communities is contributing into development for Kubernetes. So let's talk about the future of Kubernetes. So I'm not going to discuss everything into detail because this is a just beginner and installation course, but I'll post few of the detailed video for the feature which will explain everything in detail. So automatic bin packing, self-healing, service discovery, and load balancing, storage orchestration, batch execution, secret and configuration management, automatic rollbacks and rollouts, horizontal scaling. These are few features which Kubernetes offer. Other orchestration tools also available, but I think the way Kubernetes offer and the easiest way to do is better than any other tool. It is my opinion. So how Kubernetes works? So Kubernetes brings together individual physical and virtual machines into a cluster using a shared network to communicate between each server. The other machine in the cluster are designated as a node server responsible for accepting and running workload using local and external resources. So basically Kubernetes work in a master and slave environment where all the configuration resides over the master and nodes serve as a container which we also call as a pod. So this is a Kubernetes architecture. So again, as this is a beginner course, so I'm not going to discuss into the detail. Soon I'll have a detailed video how the architecture works, how it works, and I'm going to cover all entire detail in advanced course or advanced session. But here, let's go to some of the basic feature of architecture. So you can see the UI and CLI, the kubectl, and Kubernetes master actually have API server, scheduler, controller, manager, and etcd. And suppose here we have a two worker node 1 and worker node 2 that you can see in pod 1. As I mentioned, pod 1 is is also a container. So pod 1 we have inside three container: container 1, container 2, container 3. Pod 2 has container 1, pod 3 has a container 1 and container 2. And worker node 2 same again, is it has container 1, container 2. Pod 2 has a container 1, container 2, and container 3. And pod 3 has a container 1, and these all are on top of the Docker environment. And here kubelet and kubeproxy is playing the role. So we'll discuss this further in next session. So let's move on to our lab session. So Kubernetes installation, there are n number of way we can install Kubernetes cluster. So these are kubeadm, which is bare metal installation, minikube, virtualized environment for Kubernetes, COPS, Kubernetes on AWS, and the last one is Kubernetes on GCP, I mean Kubernetes running on Google Cloud Platform. But here we are going to work on Kubernetes kubeadm, which is a bare metal installation, and we are going to utilize the AWS environment, Amazon AWS console. So let's begin our session. Here you can see my desktop. I'm logged in my AWS console. I already configured, I have two instances running, which I named as a kmaster and knode. So just begin. Let's start. I'm going to log in on my kmaster. I'm going to give my auth key and just change the color so we can identify. So make this for master. True. And again log in into the node. So here is the IP for node. Start new session. Give auth key. Let's wait in white background. Yes, sir. Into. So let's first update the server. We'll use sudo apt-get update. Let me expand it for you so you can see. So this is my master node. Now update the node. Sudo apt get oops, sudo apt get update. And now this is updating. In the meantime, come to the master and install Docker. So command is sudo apt get install docker.io. Say yes. Installation begins. Go to the node. Sudo install docker.io. Say yes. So it's installing Docker. So for Kubernetes, as you know, we need Docker. It's not necessary. There's other containerized tool which Kubernetes support, but for this demo purpose, we are using Docker. So installation done. I just cleared the screen. Now we are going to install Kubernetes on master. So I'm going to copy and paste the command. Yes, done. I to run the same command on master. Sorry, slave. Now copy Kubernetes main. Run the same command to the. Let me clear the screen for you. So you can. Okay. Now Let me run sudo apt-get update again. So before that, just we can check the Docker version. Here you can see Docker version 19.03.6. So in this node also, if we can check, just want to make sure. So here it is. So let's update this one also. Sudo apt-get update. It's getting updated. So now install kubelet, kubeadm, and kubectl. And at the same time update this on node as well. So this is done. Let me clear the screen one more time. And now run the command sudo apt mark hold kubelet kubeadm kubectl. We are running this command, so the app version, I mean the kubelet kubeadm and kubectl version should not mismatch. I mean, it's not like master having some another version and node having some another version, which will break the cluster. So we are just holding it. So we have got prompt, all are on hold. Again here. So now come to this. So now go to the master and use command. Okay. Oh, okay. So it's getting some error here. So you hit the command and this error was expected as Kubernetes required at least 2 CPU, but here number of available CPU is less than 1 than the required 2. So we need to ignore these error by using the command which is already given here, the ignore pre-flight check, and give the error name. Error name is num CPU. So you can see it's installing and it's initializing the QVDM. So let's wait. In the meantime, when it's initializing the kubectl, I'd like to refer you this Kubernetes official installation document. The link you can see here, the kubernetes.io. The documentation is pretty much self-explanatory. You can refer those if you face any issues or any problems. So let's see the status. is putting up. Okay, so this is kubeadm has been initialized, but the process still not completed. It says your Kubernetes control plane has initialized successfully. To start using your cluster, you need to run the following command as a regular user. So let's run this command. Run. I'm copying it one by one. Done. And done. Now we have given the pod network CIDR. So and we have used it. We have used the Calico for this installation purpose. So we need to apply this setting onto the master. Go to the master, apply this setting, and you can see it's getting up. Deployment has been created. So now if you want any node to be joined this cluster, you need to copy this command, which is already given here, and I think you need to go here, copy this into the, okay, I know where is the problem. The hash is not captured properly. Now let me just try with Control A. I think no problem. Okay, I can make it, I copy it. An error. Sudo warning. Yeah. This thing starting the kubelet. And in the meantime, if you'll go to this node, and so our kubeadm command has been finished. After that, we are not going to use kubeadm here. So the command is kubectl get, let me first clear it for better visibility. So kubectl get nodes. Here you can see the IP address for master, IP address for node, and it says not ready. Let me see here. So it says this node has joined the cluster. So let's wait for it. Kubectl get nodes, and there we go. Now we have both the master and node up and running. So kubectl get pods. So as we do not have any pods available here, we do not see any resource. So guys, this was the installation for Kubernetes on Ubuntu 18.0 server. I used AWS. So thanks a lot for watching it. In next session, we will be working on Kubernetes security. I'll make sure I'm making a detailed video which will cover all the security stuff of Kubernetes security. Thanks for watching.